Okay, so to get us started on what these parent sine and cosine functions look like in terms of the graphs, it's probably easier to do a little bit of a sketch before we get into all the characteristics of these two independent graphs. So before we do that, I want you just to briefly look at the next page where it says parent sine and cosine function. The graph that's given to you, the first one is actually your sine, your second one is your cosine. And there's a couple things I want you to look at. The first is for my sine value, our graph in particular, our x-axis, I should say, is given to us in degrees, and our y-axis is actually our sine value at those specific degree measures. In the same light, our cosine graph, our x-axis, is also given to us in degrees, and our y-axis is given to us as our cosine values at those particular degree measures. So how do we get there? How do we go from using a unit circle for our trig functions to all of a sudden we're looking at these two different graphs that you've never seen before? And here's my best and easiest explanation, and this is kind of how I always thought of trig. This is our unit circle, and we've used this actually pretty frequently over the past couple months, but this is our unit circle that you guys know pretty well. And the importance isn't necessarily knowing all the information that's on there. I'm just wanting you guys to look at the fact that we have here a circle for our unit circle, and we pull all this information off. And in this unit circle, we have a ton of information that's given to us. We have our x and y here, which are actually given to us as angle measures in degrees and radians. And we have all these ordered pairs all the way around our circle. Our cosine represents our x value, our sine represents our y value, but we're looking at a circle. And so when I usually teach this trig, I have my students remember back to the golden rule of our vertical line test. If you guys can remember back probably around Algebra 1, you learned about a vertical line test, which was basically taking a pen or pencil, you're holding it vertically, and anytime you pass through a graph or a function or a graph of some sort that hits vertically at more than one point, you guys have known this to be not a function. So when we look at other graphs, like a linear graph, if I take my pen and I follow it from left to right, at every given moment I'm only hitting at most 1 point vertically on my graph. So this would be a function. So if we use our trig functions and we keep our graph as a circle, we wouldn't be able to look at these type of expressions as a function because the unit circle itself is considered not a function. So we have to go back to our unit circle and we have to pull out pieces of information individually so that we can get a graph of sine and cosine that is considered a function, because our circle again is considered not a function since at this point or any other given point inside of our circle we're hitting more than 1 point at a given time. So, and I'm kind of running out of paper here, so I'll flip this over. So the idea is we have a unit circle. I'm going to sketch this again, and you don't really need to write this down. We'll talk about this again the next time that we all meet. The idea is that we have a unit circle of information. And the easiest points to graph, if we had to plot points on a coordinate plane, the easiest points to graph on a unit circle happen to be our quadrantal angles, right? Our quadrantal angles are 0 degrees or 360 degrees. They're coterminal, so they exist in the same spot. We have 90 degrees, that's quadrantal. We have 180 degrees, that's also quadrantal. We have 270 degrees, quadrantal. So we have 4 quadrantal spots, but we technically have 4 quadrantal angles since all 4 or 5 of these angles lie on an axis and not in a quadrant. I think you guys remember that back from lesson 1 and 2. So at these certain points in our unit circle, we know we have the ordered pair 1, 0, we have the ordered pair 0, 1, we have the ordered pair negative 1, 0, and we have the ordered pair 0, negative 1. And those happen to be the easiest points out of our entire unit circle to be able to plot because they're nice whole numbers, as opposed to looking at something like 30 degrees where we have the square root of 3 over 2 and 1/2. So our quadrantal angles tend to be the easiest angles for us to use to be able to plot or use them to be able to graph our sine and cosine functions. So if you look back at your parent and cosine functions, the sheets that's on your Blackboard assignment number 12, a couple things I want to point out. So we're going to pull out information from our unit circle, and more importantly, we're pulling the information out of our quadrantal angles, so just these angles that you see here as we start. And we're going to match them to the graph that we have as our sine and cosine functions. So the first we're going to look at is we're going to look at our sine. So we're going to look at this guy first. And sine happens to be, if we look at our ordered pair, cosine tends to be our x, sine happens to be our y value. So sine, at any of these given angle measurements, sine is going to be the second value that we have. So if I look at my first pieces of information on my unit circle, at 0 degrees, so I'm just going to write this down, 0 degrees, my sine value is 0. If I go to my next quadrantal angle, which is 90 degrees, my sine value for 90 happens to be 1. If I keep going around, my next quadrantal angle is 180 degrees, and at 180 degrees my sine value is 0. At 270 degrees my sine value is the second one, which is negative 1. If I go all the way around my circle to 360 degrees, so I've done one complete circle around my unit circle, I go back again to my sine value being 0. Okay, so what I'm going to do here is I'm going to take those values, I'm going to slide this up, again we're looking at sine only, we're going to take these values and we're going to create a new set of ordered pairs where we can pull this information and create a graph that is a function. So down here, I'm going to slide this up again, just remember 0 degrees, 0, 90 degrees, my sine is 1, 180 degrees, it's 0, 270 degrees, I get negative 1, 360 degrees, I get 0. So, I'm going to make a new sine graph, and in my new sine graph, my x-axis is going to be my degrees, and my y-axis is going to be my sine value. Alright, so we're changing this up a little bit. We're changing what our axes mean so that we can create a graph for sine that is a function. So my x is now representing my degrees, my y is representing my sine value. So again, my quadrantal angles, I have 5 of them, right? 0 degrees all the way around to 360 degrees. I have 5 quadrantal angles. So at this point, I've got 0 degrees. I'm going to go to I'm going to go a unit over. We're going to call this 90 degrees. Go about the same unit over. This is my next quadrantal angle, which is 180 degrees. My next quadrantal angle after that is 270. And my last quadrantal, if I do one full circle all the way around, I get 360 degrees. Okay, so using that value, the values of my degrees, I'm now going to move on to my y, my sine values. Okay, so my sine values, which are my y, if I go back up here and I look at one full circle around, I extracted this information. I know my highest sine value is going to be 1, and my smallest sine value is going to be negative 1. Okay, so if I go down here, I know my highest sine value is going to be a positive 1, and my lowest sine value is going to be a negative 1. And just kind of make sure that you kind of sketch them equidistant from each other. So all I'm going to do now is I'm going to take this information I extracted from my unit circle up above. I'm going to go down here and I'm going to make some ordered pairs. So at 0 degrees, my sine value is 0. Then 0 degrees, 0 is a point I need to plot on my graph. So at 0 degrees, 0, I know I have a point at that spot. My next degree is 90 degrees, which gives me a sine value of 1. So my next ordered pair is 90 degrees, 1. My next ordered pair after that is 180 degrees, 0. 270 degrees, my sine value is -1. So 270 degrees and -1 is going to be a point on my sine graph. And then my last one is 360 degrees and 0. So since I have 5 quadrantal angles, I should have 5 ordered pairs. Alright, so moving this down, or moving it up I should say, I'm going to plot these points on my graph. So at 0, 0 I have that here. At 90 degrees I have a sine value of 1. So at 90 degrees I know my sine value is 1. At 180 degrees I know my sine value is 0. At 270 degrees I have a sine value of -1. And at 360 degrees I have a sine value again of 0. And if I go through and I draw a line and curves that connect these dots, I get a graph that looks similar to that. So one full time around my unit circle, right? I go from 0 degrees all the way down around to 360 degrees. I get a graph by just extracting from these quadrantal angles, extracting what my sine values are. I create ordered pairs with my x-axis as my degree, my y-axis as my sine values. I just created a graph that when I take my pen and hold it vertically and I slide it all the way over, it hits only one time along the way. So it passes my vertical line test, so I know that this is in fact a function. As we go through this one time around my circle, if you remember back to the vocab on the other page, this is what we call a period. Alright, so your period starting at 0 degrees to 360 degrees, one time around my circle. The period around my circle here is 360 degrees. So at this point, all the way around my circle, I didn't repeat anything at all. I started at 0, I went all the way around back to 360 degrees, and I got a graph that looked like this. Now at this point, if I go around another time around my circle, or I go around the back way, then I'm going to keep repeating the same pattern. Okay, and as I repeat the same pattern, that's where we get that sine and cosine functions are periodic. Alright? So the idea is that this is one period, one piece of your circle all the way around that looks just like this. If we keep going around our circle in the positive direction or the negative direction, which is clockwise, we're just going to keep repeating the same pattern. So this is what your sine function looks like. So if you take your parent sine and cosine function, you would notice that the graph that is in front of you on this page and the graph that we sketched together are going to look the same. Alright, so in the next video what we're going to talk about is cosine. We're going to talk about how we can extract those cosine values and build a graph that's going to look like this.